This is the K500 imploder. What we're doing here today is a test of the creation of large particulate of glass from container glass. The simple test we're going to conduct is to feed full container glass through a temporary feed hopper that has been added to the K500. This container glass is held in regular dustbins, and we're quite simply going to lift those bins to the top and feed it through. So we'll ask Chris now to start the machine. Now this machine runs with a hydraulic drive which is located around the rear of the imploder, just at the back here. This hydraulic system is driven by an inverter drive located in the panel. After 40 seconds of the hydraulic drive running, you can hear the imploder now kick in, coming up to speed, and as you can hear, there's not a discernible difference between the tone of the hydraulics running and the imploder. So I'll now ask the guys to feed the glass. Definitely empty. Okay. All Chris is doing here is just placing this temporary container under the discharge. The discharge of this machine would normally have either a channel feeder, a conveyor, or alternatively a grader attached below it. Now Chris is showing us here that we just have full containers. They're typically wine bottles. Now the guys will feed that to the machine. The settings we have on this first test are with the imploder running at 65% and the tolerances of 35 millimeters. The second test will be conducted with the imploder running at 100% and with the imploder tolerances still at 35%. What Chris is going to do now is draw the container from below the machine. Now let's pan in and have a look at the glass. There's some fine fragments on the surface, but you'll see there's plenty of large fragments included. What we're going to do now is take this glass to the outside of the factory, where we will undertake some simple screening trials, just using garden screeners. I'll show you that the necks of the wine bottles, the aluminium ringlets are released. Chris is kindly moving those around there and indicating, let me zoom in, indicating that those have been liberated of their glass with very little damage to those items. So we'll let Frank throw that to the side. As you can see, as a percentage, it's roughly 70% oversized material, and the subsequent screened material is equally sized. That's the finish of this first demonstration. It's now our intention to run the same demonstration running at 100%. We're here now running the second demonstration, which is to run the K500, which you can see in front of you, at 100% with 35 millimeters of tolerance. This second trial is to indicate the difference in percentages between the two speeds. The principles are the same. We're using container glass of the same type, wine bottles. We're running an empty grey container, and as we say, we're going to be running at maximum speed. Again, you'll notice no discernible difference in the noise or speed of the processor. And I'll ask Chris now to fire the machine up. Whilst the machine's coming up to speed, I'll show you the hydraulic system. So we have an 18 kilowatt hydraulic power pack running hydraulic drive down here. The imploder also has an auto reject system built into the rear of it, which allows for heavily contaminated items to pass. This is the area that we're now panning in on, and this area allows the sizing system to be lowered automatically to eliminate heavily contaminated items. Okay, we're now ready for feeding. This machine is typically rated at 10 tonnes per hour of container glass. Similarly on CRT glass, commercial flat glass and float glass, similar tonnages. The flexibility of this process is that you can use it either as a primary or secondary imploder, i.e. produce large fragments or maybe a grit size. Chris is now going to turn the system off, and we'll go through the same exercise of grading the processed glass. As you can see, to the previous exercise, very similar quantities of oversize to fine refined. Now we're probably running here at about 65% oversize to 35% finer material. Now remember, we're screening at this stage with a 10mm screen. Now, optical separation can certainly recover a significant quantity of this material if screened more effectively. So we're probably looking in this exercise of somewhere in the region of 80% potential for recovery. We have one final exercise to conduct now, which is to take this process glass and put it through the imploder at 100% with a 3mm tolerance to indicate how we can create fine material. For the final test, we intend to process the pre-processed glass through the K500 at 100% with 3mm of tolerance, and we'll just show you what's inside these bins. It's the glass which has been already processed in both of the drums. Okay, we'll start the machine up and we'll prepare ourselves to process it. Okay, we can remove the bin. Which, as you can see, compared to the previous test we ran, we now have significantly smaller fragments. Papers are liberated from the glass where possible. Okay, we'll run through now to the sieving. Which has been sieved. You can really see the proportions here. Now, bearing in mind there's a significant volume there of dry waste material. If you were to base this on a density, somewhere in the region of 80 to 90% is within the sub 4mm category. What we'll do now is simply pan in to the oversized material and Chris will just remove some of that material, and we'll pan into the fine and have a look at how little paper there is in there. Okay, well, that concludes our final demonstration of the Krysteline K500 imploder. As you can see, it's a very versatile machine. With very simple setup and tolerance changes, you can create a multitude of different products.